The models that have been activated can be viewed using the model selection dialog. This is the best way to change the models later on. To view the models in a physics continuum, say physics 1, simply open the physics 1 node with the continua node, then open the models node. The tree view expands as shown. This is the process to set the properties of a model. First, view the models in the continuum using the object tree. Then, click the selected model. This action causes the properties and expert properties to become available for inspection and editing. The values in that category reflect both the design of the model and the discretization approaches. These need to be optimized for accuracy and performance. The virtual representation of a real-world situation in StarCCM Plus is the continua. So, continua is the central aspect of a CFD model. The simulation of continua requires a bridge between what is understood in the material world and the mathematical constructs of transport equation models. In the physical world, we understand concepts such as walls or porous media. In the modeling world, we think in terms of boundary conditions or volumetric source terms. These concepts are bridged in StarCCM Plus by defining types, conditions, and values so that the software understands real-world situations. These three entities are used to provide the continuum model's complete information for dealing with boundaries, regions, and interfaces. In StarCCM Plus, types are assigned to regions, boundaries, and interfaces. This is a way of informing the models and the associated continua how these entities must be dealt with. As much as possible, the types are analogous to physical entities so that they are as unambiguous as possible. For instance, a typical boundary type is a wall, which is a concept that most people can understand and identify with. All models in StarCCM Plus must know how to deal with the predefined types. StarCCM Plus initially assigns types during mesh import or when a region or boundary is created from within the simulation. To change the type of region, boundary, or interface, we have to follow a process. We have to select the region, boundary, or interface in the object tree. In the Properties window, select one of the available types from the drop-down list corresponding to the type property. The models that are available in the continuum determine the list of available types. For instance, the free stream boundary type is only valid for ideal gas flow. So, if the continuum does not contain the ideal gas model, the free stream boundary type is not presented. What are regions? What is the meaning of that? Regions are assigned types that models within their associated continuum use to determine what specific conditions and values are required. StarCCM Plus recognizes three different region types. These are fluid, porous, and solid. The availability of each type depends on the continuum that is associated with the region. Fluid and porous regions are available only if the continuum is a gas or liquid. Solid regions are available only if the continuum is a solid. *CCM Plus initially assigns region types based upon mesh import. Region types can also be reassigned within *CCM Plus. Regions that are assigned to gas or liquid continua are automatically assigned the fluid type. The physics models such as flow, energy, and turbulence make the appropriate modeling assumptions which govern flow in these regions. They are applicable for general fluid flow in the absence of porous media. They are available only for regions containing a fluid material. Regions that are assigned to gas or liquid continua can be designated with the porous type. The physics models such as flow, energy, and turbulence make the appropriate modeling assumptions which govern porous media flow in these regions. Where should we use porous regions? They are suitable for modeling real-world conditions like filters, tube bundles, flow straighteners, sponges, and radiators. This type is available only for regions containing a fluid material.